Okay, starting with number 73 in 3-4. Okay, so we have not outside bracket, parentheses, if P then not R, if and only if, R and not P, close parentheses, close bracket. Okay, so they already tell you what P, Q, and R truth values are, so you don't have to make a truth table for this. When you already know what it equals, then you can just substitute it in like a math problem. So if P is false, so I'm going to rewrite this, but instead of writing my P, Q, and R, I'm going to write what the truth value is. So P is false, so we're going to have a false there. R is false, therefore not R is true. Any questions so far? Okay, again, R is false, and not P, since P is false, then not P is true. Okay, so again, they already told us what P, Q, and R was equal to in the directions. So that part that I underlined there. And so all I did was substitute the value of the truth value. Okay, so now I take what I know about all these connectors and whittle it down from the inside out. So starting in one of the innermost parentheses, the only time an if-then statement is false is when it is if true, then false. Okay, so this is not that pattern, therefore this whole parentheses is true. Okay, so an and statement is only true when they're both true. These are not both true, so therefore this and statement is false. Okay, if and only if is true when they're both the same. So they're not both the same, so therefore this statement is false. But now we have not this statement, or the negation symbol means I want the opposite of what I already have here. So the opposite of false is true. Okay, so again, when you have these types of problems, you work it out more like a math computation problem. Substitute in the truth values and use order of operations to work from the inside out. Okay, we now can do a truth table for any type of statement because we've looked at all of the different possibilities. And now we're going to be able to tell what equivalent statements are. We talked about one of them already, but now we're going to go way in depth into this. And two statements are equivalent if they have the same truth values. So in other words, if you do a truth table for both statements and your final column is exactly the same, then you know that those statements are equivalent. Okay, so on your handout you have truth tables for P or Q, and if not P, then Q. Okay, so your first truth table should look like this. So if you're doing a table for P or Q, P is true, true, false, false. Q is true, false, true, false. And your OR statement is true, 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 false. Okay, for your other truth table, you had a P and a Q with the same pattern, but then you had to do the not P, and then the if not P, then Q. So again, remember that not P was your if, and Q is your then, and the only time an if-then statement is false is when you have if true, then false. So the only time that happens is down in the last row, because remember you're going in an opposite order this time. So you should have true, 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 false. Any questions on either of these two truth tables? All right, what do you notice about the last column of each truth table? Not just the last row, but the last column. They're exactly the same. Okay, so when you compare the last column, if they are exactly the same, then you have just proven that these two statements are equivalent. So what this means is that you can write an or statement as an if-then statement, and it'll give you the same meaning. So let me give you an example. I go to the beach or I go to the movies. Okay, so here's how we can write that. P or Q is equivalent to if not P, then Q. So I go to the beach or I go to the movies is equivalent to saying if I don't go to the beach, then I went to the movies. Because I said that I was going to do one or either or both. So if I didn't do one of them, I must have done the other one. Yes? Yeah, so that equal sign with 3 bars is your sign for equivalent to. Now, this works both ways. If you start out with an if-then sentence, then you can change it back to an or statement, and that would be the same, it would be the equivalent statement. So some of the problems in your homework are going to be choose the one that's equivalent to this statement. All right, let's take a look at the next one. We already talked about this one, and this sentence is not on this handout because you already wrote this on the previous handout. Okay, so you don't have to write this down again. The truth value of conditional statement does not change if the antecedent and the consequent are reversed and both negated. So our example that we used last time was if I live in Port St. Lucie, then I live in Florida. And if I don't live in Port St. Lucie, then I don't live in Florida. So this is called the contrapositive of the conditional. When you take an if-then statement, reverse it, and negate both sides, you have created the contrapositive. So in your homework, if it says, write the contrapositive of the statement, then that's what you're doing. You're taking the statement that was in words, you're reversing it, and you're negating both sides. Now, sometimes it's not as straightforward as if P, then Q. It might be something like this. If not S, then T. Okay, let's say this is your original if-then statement. So if I want to write the contrapositive, I want to reverse the order and negate both sides. Good. So that means that the T is going to come first, but I need to negate it. So that becomes a not T. And then the S is going to go at the end, but it already has a negation symbol. So just take it off, right? So the not S becomes an S because the negation of something that's already negated goes back to the original. It's almost like a double negative or minus a negative, if you will. If you had a negation, it turns back to that positive there. Okay, so if your sentence already has the word not in it, when you go to write the the contrapositive, then you have to take that word not out. So any questions there? Okay, so let's do a truth table. We have this truth table for if P, then Q. That one you've already done before. Now do a truth table for the other statement, the if not Q, then not P. You needed to create your column for P and Q, and then a column for not P and not Q, and then your if-then statement. So here's the truth table that I came up with. You might have had your not P and not Q in a different order, and that's okay. Well, I guess on the handout I labeled it, right? Yeah, okay. All right, so taking a look at the final column of each truth table, notice that this proves that these two statements are equivalent. So if you do true truth tables for two statements and the last column is the same, you've proven that they're equivalent. Okay, if you just reverse the order of the if-then statement, then you've created the converse. Okay, so notice that if Q then P, all we did was reverse the order, we did nothing more. If you keep the order the same, but you negate both sides, then you've created the inverse. Now, these two statements are not equivalent to the original if P then Q. But take a look at the converse when you compare it to the inverse. So when you compare the converse to the inverse, what do you notice about the order? It's reversed. And then what do you notice? The negation. So if you start with the converse, you reverse both sides and negate both sides, then you have the inverse. So that means that these two are contrapositives of each other. Okay, so the converse and inverse are contrapositives, and because they're contrapositives, then they're equivalent to each other. So those two statements are not equivalent to the original if P then Q, but they're equivalent to each other. Okay, so let me give you a statement here. Let's say that this is your original if-then statement. I want you guys to create the converse, the inverse, and the contrapositive. Okay, so the converse means that you're doing what to the original? Just reversing, right. So keep everything the same, but reverse the order. So we're going to have not R, then Q. Okay, the inverse means we're doing what? Okay, so the inverse means keep the order the same, negate both sides. So Q is going to become not Q, and not R is going to become R. And then the contrapositive of that original, reverse it and negate. Good. Okay, so we're going to start out with an R. If R, then not Q. Good. So any questions on either of those three? Okay, and then the rest of this slide is not on your handout, but I just went ahead and showed truth tables for the converse and the inverse to prove to you that they were equivalent to each other. Not to the original, but to each other. So here's the if Q then P is true, true, false, true. And then if I do a truth table for the if not P then not Q, I need my columns for not P and not Q. And so if not P then not Q, that's the only one that is false, so you get true, true, false, true. So notice that the final columns are the same. So if you were ever asked if two statements were equivalent, and you're just not quite sure based on what maybe you forget that the converse and the inverse are equivalent, or maybe you don't even realize that they're converses and inverses, you can always do a truth table for each one to figure out if they're equivalent. Now, I'm going to be teaching you some shortcuts as we go, in the next week as well, that will help you to determine when statements are equivalent to each other. But worst case scenario, you can always do a truth table for every statement that you're comparing and see which ones match. Okay, this is the long way to do it if you don't have the shortcut. This is what we learned about the conditional, the converse, the inverse, and the contrapositive. Okay, so if you start with a conditional that looks like the traditional one, if P then Q, then the converse means reverse the order. The inverse means keep the order the same but negate both sides. Say again? This is the end of 3-5. And then the contrapositive is where you reverse the order and negate both sides. Okay, so yeah, I guess you had a chart at the end of your handout there, and this fills in the chart.